Welcome back. Today we're still on Unit 7, Day 5. We're looking at rhombi and squares. In the last video, we discussed all the unique properties of the rhombus, which are all the properties of the parallelogram, plus all my sides are congruent, my diagonals are perpendicular, and my diagonals bisect the vertex angles. Okay, now we're going to focus on squares. The square is a parallelogram that is both a rectangle and a rhombus. So because the square is a parallelogram, it has all the properties of the parallelogram. The opposite sides are parallel and congruent, so my top and my bottom are parallel. My left side and my right side are parallel. The opposite sides are congruent, so the top and the bottom are congruent, and then the left side and the right side are congruent. And because it's also a rhombus, I'm going to go ahead and mark those all with the same single tick mark because I'm thinking ahead and I know it's going to have congruent sides. Opposite angles are congruent, so however big this angle is, the one across from it is the same. Same here. These are the same. And because I'm thinking ahead and I know it's a rectangle, I actually know what those are going to be, right? I know they're going to be 90 for all of them. Thinking ahead. Okay. Consecutive angles are supplementary. Well, that makes sense, right? Because if this is 90, this is 90. Those are 180. And then 90 and 90, 180, 90 and 90, 180, 90 and 90, 180. And the diagonals bisect each other. So I know that these two are cut into two equal pieces, and this one is cut into two equal pieces. And thinking ahead to my rectangles, I know my diagonals are going to be congruent, so actually all four of those will be equal. So I know we've already talked a little bit about the properties that are unique because of it being a rectangle. So since it's also a rectangle, that's how I knew that these opposite angles that were congruent and these consecutive angles that were supplementary. Since my consecutive sides are perpendicular, remember that upside down T that's real little there? If you don't remember that that means perpendicular, you better write it down. If you don't remember that perpendicular means 90 degrees, you better write it down. Okay? Consecutive sides are, and upside down means perpendicular. And that's because it's a rectangle. Here and here, here and here. And because it's a rectangle, my diagonals are congruent. So if I were to label this A, B, C, D, notice I went around my figure. I did not zigzag, for I can't put my C over here. These diagonals AC is going to have the exact same measurement as BD. Then, because the square is, not only is it a parallelogram, not only is it a rectangle, but it's also a rhombus, it's going to have those properties of the rhombus as well. All four sides are going to be the same. My diagonals are going to be perpendicular, so when I draw in those congruent diagonals, I know they're congruent because it's a rectangle. Not only are they congruent, but they are going to intersect at a 90-degree angle. And then because it's a rhombus, I know it's going to bisect the angles in the corner, so I know these are going to be the same. Now I know already, since it's a rectangle, that they're 90, so I know when I bisect them, they're going to always be 45s. And we talked about that when we talked about our 45, 45, 90 triangles, right? So again, sorry I didn't draw that very neat. 45, 45, and 45. So all of those little tiny angles in there, I need a bigger square, all of those little tiny angles in there are going to be 45 degrees, and then that angle in the middle is going to be 90. Okay? So what's kind of unique about the square is it doesn't have any of its own properties. It just takes all of its properties from every other type of parallelogram, from the parallelogram and the rectangle and the square and the rhombus. It has everything from everything else, and it doesn't have anything that belongs to just it. Okay? Alright, so let's see. Let's look at an example. If MNPQ is a square whose diagonals intersect at A and PQ is 3 square roots of 2, find each measure. So the first thing I want to do is I want to sketch that picture. MNPQ is a square. So I'm going to draw myself a square. Okay, so if this is a square, MNPQ, I can pick anywhere I want to put the M. I, again, usually go in the upper left-hand corner, and then I usually go clockwise. As long as you don't zigzag when you label, you're good. So M, if I put the N here, I cannot put the P over here because I cannot zigzag. The P has to go underneath, and then Q. Okay, so P has to be on the same, leaving a segment from N. All right, the diagonals intersect at A. So I'm going to draw on my two diagonals, and I know they are going to intersect at A. And I know PQ is 3 square roots of 2. So this is 3 square roots of 2. Okay? Now, I kind of casually mentioned up here that, oh, we've already talked about how when you put the diagonal in a square, it makes that little 45, 45, because that's where we got our 45, 45, 90. Remember, our 45, 45, 90 rules are going to come into play here, so we want to review what they are. When I have a right triangle with the two acute angles both being 45, I know these legs are both going to be the same, whatever they are. And then I know the hypotenuse is going to be whatever that leg is times the square root of 2. And remember, we did have two patterns. We had that as one of the patterns, and then we said, well, sometimes though, accidentally, or not accidentally, but just incidentally, sometimes when I have a 45, 45, 90, instead of having that square root of 2 over here where I normally see it, sometimes my square root of 2 is on my legs. And so that pattern ended up having that number that was in front, it actually doubles that number and takes off the square root of 2 to get to the hypotenuse. So remember, there were two patterns. There was pattern 1 and there was pattern 2 for my 45, 45, 90 triangles, which is really going to come into play when you're working with squares. Okay? So let's look and see what we have here. There's a couple different ways I can do this. I can think of this whole bottom side as a triangle. I can think of this whole bottom side as a triangle. Or I could look at this little piece right here as a right triangle. I know it's a right triangle because I know, since I have a rhombus, my diagonals are perpendicular. So I know I have a 90-degree angle here. I know I have 45 and 45. My hypotenuse is 3 square roots of 2, x square root of 2. So my two legs were both 3. All right, and then because it's a parallelogram, I know my diagonals bisect each other. So if I know one half of the diagonal, I know the other half of the diagonal. So all of these inside pieces are all going to be 3. Since it's a rhombus, all my sides are the same. So if one's 3 square root of 2, my other sides are all 3 square root of 2. All these angles in the center are all 90. And these angles at the corner are all 45. Once I have everything filled in, these blanks are going to be super simple to fill out. Watch this. A to Q. A to Q. I almost forgot where my A was. A to Q is 3. Then the next one, the measure of angle APQ. The measure of angle APQ. So that's this angle here is 45 degrees. Okay. The measure of angle MNP. MNP, that's that whole corner there, which I know is going to be at 90 degrees. And then the distance from P to M. From P to M, that's this whole diagonal, which I know is 3 and 3, so that is 6 units. Okay? Alright, the next thing it wants me to do is draw a square with diagonals and find all angles and segments. So it wants me to just solve the square, which is what I did here. What we call solved the square. I found every segment, I found every angle, everything is good. Okay, so I'm going to do where I have one side that's 4, and then I'm going to do one that has a diagonal that's 20. The first thing I'm going to do is I'm going to draw both of my squares, because there's something that every square is going to have in common, so I might as well just do that first, since both squares, both of these, are going to have those properties. Okay, we want to draw the diagonals. Draw the diagonals. One side is 4. One diagonal is 20. Now, if the whole diagonal is 20, so from here all the way to here is 20, that whole diagonal is 20, I'm going to use that information to figure out what each of my half diagonals are, right, when I'm solving this. Okay, so the first thing I'm going to do is I'm going to do all the angles, because from every single square I have, my angles are never going to change. The ones in here are always going to all be 90. And the ones at the corner are always going to be 45. Same over here, these will all be 45. Okay, all right, so then I need to find my sides. On the first one, they gave me that one side of the square is 4, so I know all my sides are 4. Okay, then what I need to do is figure out what those diagonals are, right? If I have a side that doesn't have a square root and 2 on it, I try to make that to where it looks like number 1, because then I know to get my hypotenuse, all I have to do is stick a square root of 2 on it. So if I look at this right triangle, right here, that has my hypotenuse as one of the whole diagonals, okay, then I know I'm going to be 4, 4, and then this whole diagonal will be 4 square roots of 2. But remember, we're going to divide that into 2 equal pieces. So each one of these will be not 4 square roots of 2, but half of that. 2 square roots of 2, 2 square roots of 2, and then same for this diagonal. I'm going to have 2 square roots of 2 and 2 square roots of 2. So I've got every segment and every angle labeled. When I look at the next one, if this diagonal is 20, then that means it's divided into 2 equal pieces. This is 10 and this is 10, which means this is 10 and this is 10. So then instead of looking at a whole corner, I'm just going to look, since these are nice pretty whole numbers, and this is a 45, 45, 90 triangle, I know I'm going to have 10, 10, and 10 square root of 2. So all my sides are going to be 10 square root of 2. So it'll be the same process for every square you'll ever come across ever in your life. Okay? So hopefully that helps. In the next video, we're going to look at classifying some shapes, and then we're going to touch on area of rhombis and squares. All right? So come on back for the next video.